Hello everyone. In today's session, we'll be discussing about the different control flow instructions. These are the instructions which will decide which particular instruction executes next, instead of always executing instructions sequentially. So what does this mean? Let's assume we have some set of instructions. In which order will these instructions be executed? First this will get executed, then this will get executed, followed by that this instruction will be executed. So what does that mean? All instructions here are getting executed sequentially. Let's assume once I'm done executing this particular step, I want to skip these instructions and directly execute this particular instruction. So what am I supposed to do? In that particular situation, I'll have to use control flow instructions. Okay, and one example for that is branch instruction. Okay, I can directly write something over here. Okay, something like branch to ABC. Then what will happen? Immediately the control moves here and this is the instruction getting executed. That is one use case of control flow instruction. Okay, but just branch is not the only instruction available under the control flow instructions. We have multiple categories under it, and those are branch, conditional branch, subroutine instructions, and software interrupt instructions. In today's session, we'll be focusing on these three topics. Okay. The very first category under the control flow instruction is branch instruction. We already saw one example of that. We use something like branch followed by ABC. So what was this ABC there? It was nothing but a label. So what is a label? Label is a name or an identifier which is used to mark a particular memory location. So what does that mean? While we write the code, let's assume these are the different codes here. Okay, we usually group it under a particular name, for example ABC here. Okay, what actually happens is this data is stored in certain memory address. Okay, that address is marked by this particular name. So whenever I use this particular name, the address associated with that will be the location where the branch happens. Okay, they have given this particular example, and as specified here, this instruction causes the processor to jump to the instruction labeled loop. Okay, but there is something more you need to know. What happens internally when a branch instruction is specified? We know that based on the content of program counter, which is nothing but your register R15, the address of the next instruction to be executed is determined. Okay, so if you modify the content of PC, automatically the control moves to the next specified location here in order to execute the specified instruction. Whenever this instruction is encountered, label will be having some address. That address is updated in the PC, and an unconditional jump happens. That is, without checking any conditional code or without checking anything, directly the next instruction getting executed will be the instruction which comes under this particular label. Okay, just now I told it's an unconditional jump because we are not checking anything, we are directly jumping to the specified label. So the very next topic that we see here is conditional branch instruction. So this is nothing but conditional jump. Okay, so what does that mean? Here conditional execution happens. Instructions will be executed based on the conditional flags. Only if the determined conditional codes are true, okay, then that particular branch will occur. If that particular code is not true, in that particular case branch won't happen. For example, here we have instruction like BEQ. Let me take something like BEQ followed by AAA. Okay, where AAA is a label. Let me consider some addition happening here. So what exactly does it mean? In this particular line, what exactly is checked? Z flag will be checked. What EQ means is check what is stored in Z. If it is equal to 1, this particular condition is true, because of which branch occurs. If in this particular situation Z was 0, then branch won't occur. The next set of whatever codes are there, they will get executed. But if Z is actually 1, then branch occurs to this particular label and these set of instructions are executed. Okay, and same thing happens in all these cases. This is branch if equal, branch if not equal, branch if greater than, branch if less than, branch if greater than or equal, branch if less than or equal. These are not the only conditional codes possible. I have made 2 videos just on the different conditional codes supported. You can check that to see what are the possible instructions we can have here. We have N, Z, C, V, 4 different flags, okay, based on which this conditional codes work. Okay, so based on the content of this particular flag, it is determined whether branch occurs or doesn't occur, or based on these conditional codes, which in turn are dependent upon the different conditional flags, it is determined whether branch occurs or doesn't occur. Okay, so this was about conditional branch instruction, which is nothing but branch itself, but which works based on certain condition. Okay, and even here, in case a particular condition is true, like let me take the previous example. If this particular condition is true, then PC or register R15 is updated with the address marked by this particular label. Okay, next we have subroutine instructions. So what exactly does that mean? See, in general, what we noticed is if you write something like branch or branch followed by some conditional code and some label, okay, under the label, whatever instructions are there, let's assume add R1, R2, R3, and directly it will jump here and perform those set of instruction. But what if there is some instruction like move R1, R2, and my aim is to carry out this task and return back here. One thing you notice in branch is it will branch to some label, but there is no concept of returning back from there. Okay, there comes the concept of subroutine instructions. What happens here is, along with jumping to some location, we have a concept of returning back to the next location. How do you think that is possible? Now here you might think that you might add something like AIC, this is the label. If I write branch to AIC, it will return back here. Yes, that is true, but you have to hard code it. But there are more efficient ways to carry this particular task. Let's see what it is. Before that, let's know some terminologies. BL and BX. What is BL? BL means branch with link, and in the next slide you have something called BX, which is branch and exchange. So what are these? So what happens here is that instead of just using a branch, I'm using branch with link followed by a label. Here under this there are certain set of instructions. Once all my instructions are over, I'm using branch and exchange instruction followed by link register. So let's understand what happens here before going through all these points. Whenever you think about branch with link, there are 2 registers getting affected. One is program counter, as we expect. One more is link register. We already know program counter needs to store the address of next instruction to be executed. But what about link register? This register, this is nothing but register R14. This is used to store address of the next instruction where you should return after executing certain subroutine. Okay, so what will this store? If this address is 0x48, in that particular case this address will be stored in link register. And what is the advantage of doing this? Once you branch here, you perform certain task. After that, when you use branch and exchange followed by link register, you don't need to have any labels here. It will directly come back here to this particular address wherein the next set of instructions are stored. Okay, so what happens in BX or branch and exchange? What BX does is it will load whatever content is stored in LR into PC or program counter. That is the first thing that it will do. One more thing that it will do is, obviously it's a 32-bit data, correct? So you know there are 32 values here, right? What BX does, that is one more task that BX does, is it will check what is stored in the 0th bit of LR. Okay, if this bit has a value 0, when it returns, the set of instructions expected here are ARM instructions. If the bit stored here is not 0 but is 1, then what do you think should happen? While returning, it will expect not ARM but thumb instructions. What is thumb? Thumb is a 16-bit instruction set offered in ARM processors. Okay, so BX not only makes sure you return to the next instruction to be executed, along with that it checks the LSB bit present in the link register and ensures whether the mode that you return back to should be ARM mode or it should be thumb mode. Okay, let's go with the explanation. The BL instruction is used to call a function or a subroutine. Now this thing is a subroutine. Why do you think it is a subroutine? Because we have a specific mechanism to jump to this particular subroutine. Along with that, we have a mechanism to make sure we end up coming back to the next line which needs to be executed. And in order to execute this particular subroutine, we need BL and BX instructions. So what is a subroutine? It is nothing but sequence of instructions. It need not be a one-line instruction. There could be certain, a set or a block of code here under addition. Okay, and you can have any label as such. Okay, so this particular subroutine is nothing but sequence of instructions designed to be executed when called, okay, and usually returns the control to the calling code after completing its task. Okay, and subroutines are always reusable codes which can be called from multiple places in the code. Okay, BL saves the return address in link register before branching. Okay, in branch and exchange, this is used to return from a subroutine. The instruction copies address stored in LR back into program counter, returning the control to calling function. Along with this, ARM, thumb switching happens due to this instruction when it checks the LSB of LR. One thing you should remember, BL never changes the modes. Okay, BX is the one which changes mode, but when you are using BL, we know LR, that is link register, is updated. During that time, based on what value is set in the LSB of LR, BX instruction returns back to ARM or thumb.